Hello and good day to everyone watching. Our group have decided to do a study on body mass index, or which we familiar more as BMI, of male preschool students. But first, I would like to introduce my teammates. We start by myself, Putri Amazleka, and next we have Kurato Ain. After that we have Nur Zulaika, and lastly of our group member is Nur Ashiki. Since we already know my teammates, I'm Putri Amazleka gonna present our introduction. So as we all know, body mass index often used as an indicator to assess the growth and health status of somebody. So for preschool children, maintaining a healthy BMI is important as it reflects of their proper nutrition, physical activity, and also overall health of them. So this study focused on the BMI of 10 male preschool students. The collected data then analyzed by us to determine the relationship between the variables and to identify the best correlative that fits the BMI data. And we analyzed the data by using Maple software, which provide us with powerful tools for mathematical computation, curve fitting, and also graphical analysis. By using Maple, our study aims to generate the most suitable quadratic equation and visualize the BMI trend clearly. So therefore, by studying the BMI patterns among preschool students, we can provide useful information about the development of the preschool students. Okay, so here is our dataset. We obtained this dataset from Script Web, and it was uploaded by a teacher for educational purpose. So from all the list that was given, we choose only 10 male preschool students. Okay, for now, I'm gonna pass the next presentation to my friends for manual calculation.
Hi, my name is Zulaika. I will explain about manual calculations. First thing first, we need to change the data into a linear equation that is y equals to a plus bx plus cx squared. Then we transform it into a matrix form that is ax equals to b. Now we will check the consistency of the system by elimination row operations. Now we will see at the slide, we use row echelon form to get the result. And the result is, since row 4, 5, 6, 7 until 10 is a false statement, we assume that the system is inconsistent. After we get the inconsistent system, we need to change it to the normal system by using the formula. But before that, we need to have A transpose A, A transpose B. But in this slide, we can see that A transpose A, we will get 10, 55, 385, and so on in 3x3 matrix. As A transpose B, we can get 154.96 and 849.8, 5938.26 in the matrix of 3x1. Now we go to the formula for normal system, that is A transpose A x equals to A transpose B. So we already calculate A transpose A earlier, and we already calculate A transpose B also. So in this slide, we will just substitute what we got earlier in the formula, and we will reduce the system by using reduced row echelon form. So we get the result. The x is A equals to 15.644, B equals to negative 0.0213. For the C, we get negative 0.0008. So after we find the x, we substitute A, B, C into a linear equations. Now we will find the error vector and magnitude error. For error vector, we will use a formula of E equals to B minus AX. As we can see, we already calculate x is equals to ABC, and then we just multiply and minus, and we get the answer. For magnitude error, we just use norm E to get the answer for 4.2231.
I am Norashiki Menti Imran and I will explain to you about the maple calculation. The first thing first, we need to declare x and y, and then we need to plot a graph. We need to declare a new function which is d, and then use function point plot x and y, the color and the shape, and then we use function display d, and then the graph will be generated. After that, we need to declare matrix A, which is A1, X and X squared, and then B, A and Y, and then we have to reduce row echelon form from matrix B. After that, we have to transpose A using function transpose. After that, we need to declare a new matrix which is ATA in order for us to find the determinant of ATA. Same goes with ATB, and then we got the new matrix which is we declare as a M from ATA and ATB. We need to reduce row echelon form for matrix M, and then we got the answer for best quadratic curve. Then the answer we have to declare Y, and then we have to plot the graph using function plot x, y, and then the range is negative 40,000 until 40,000, and then we use function display, and then the graph will be generated. Last but not least, we have to find the error vector and then the magnitude from error vector. This is the command from Maple, and then we just write it, and then we got the error vector and the magnitude.
And lastly, I will talk about the analysis and conclusion for this project. Based on the calculation for manual calculations and Maple commands, we got a similar result for each variable. The result for the best fit curve is quadratic at the maximum value of error vectors. The graph does not form in straight line but curved line because there is a coefficient x squared in the equation. For the magnitude error, we obtain that 4.223 indicates that the model gives a reasonably good approximation of the data. Also, the data is a unique solution because there is a determinant of the data is non-zero. Hence, the body mass index BMI of the 10 preschool math students successfully produced a quadratic best fit equation with a small residual error and a unique least square solution.